next up, please join me in welcoming Murli Venkat to the Nanox stage. Murli is a system architect and principal engineer at Cisco. He leads the SONiC Smart Switch engineering architecture and delivery and has previously worked on multiple generations of NPU ASICs and platforms across service provider access, pre-ag, and mobility. And by the way, this is his second presentation today, so which is amazing. Please welcome Murli.
Hello. Am I audible? Yeah, okay, cool. Hi, everyone. I know it's 2 talks before beer, so bear with us. 30 minutes, a lot of light on my face, but hopefully I can see you. I want to introduce Fred. Fred Gao is my co-partner and a principal engineer at Cisco. He has worked on various platforms, XR, Junos, name it. He's done all the stuff. So together we are going to talk a little bit today about SONiC VPP. And I don't know how many of you are familiar here with SONiC. Maybe, quick show of hands. I see a few. VPP, any takers? Quick show of hands. Okay. So this is a developer geared topic, but I'm going to simplify it down to what we are trying to do here. Primarily, we run a work group in SONiC, which is the virtual data plane work group. And Fred and I co-chair that work group, and we are doing this project under the ambit of SONiC. I want to kind of show what is possible with SONiC today, and kind of lead you with a few takeaways and things that you can do in your environments and in incorporating things that you want to do with SONiC. So with that said, I think the clicker is here. Okay, so we want to talk about a quick view of why SONiC, what SONiC does for you, and give you a little bit background on VPP if you haven't heard or played with it, and it's also another open source project. And we will also talk about some of the features that we have built into this framework and how that may be useful for some of the work that you may be doing. And we'll also leave you with a few kind of variants of what SONiC VPP can do for you in your ability to do more testing, a sandbox, use it as a sandbox, or build out your IP Ethernet fabrics. You can do a lot of things with SONiC or SONiC VPP. And we'll also share a little bit of what we are doing in the community with Azure, where SONiC is actually housed as a Linux Foundation project. And we'll also talk about a few other community use cases, people who are using SONiC VPP and what they're actually doing. And some of them are SPs, and you may be familiar with one or more of them. And we'll also have a little bit of, maybe you can join hands with us. Okay. A quick view, I borrowed this slide from morning also. So we talked a little bit about SONiC and Dash under the umbrella of Smart Switch. SONiC is your NOS for the NPU, and it can run on any multiple vendor switches or ASICs, if you will. And it's a layered operating system. It's a little bit more modernized, containerized, modular system. It builds off of an infra software layer with base BSPs and a bunch of routing protocols, all of that glommed together. And it has a manageability layer built on top of it, right? No different from any other, but it's a modernized version of an open source NOS. On the other side, you have a Dash, which is a distributed API for SONiC hosts. Think of it as SONiC Lite, built for things that can run on DPUs, FPGAs, SmartNICs, what have you. And here you have an API that is really programming an overlay services application in a similar manner as what the NPU would do. And that runs primarily on DPUs. So together, you have SONiC on the NPU and Dash on the DPU. You could use either depending on your model of operation. Okay. So why SONiC VPP, right? Given that we are doing an open source on open source, VPP is an open source project, also a Linux Foundation effort. It's under the umbrella of fd.io. SONiC is running as a Linux Foundation project as part of SONiC work group. Really, SONiC does not have a compelling software data plane. That's the bottom line. It has something called a VS, which is a non-existent set of features. It's a very lightweight, testable infrastructure, not really useful beyond, base functionality. So VPP gives that credence. So VPP is a really a high-performing, fairly heavy feature set, fully compliant for various interoperability testing, also open source and community-driven, and can run on any commodity hardware, right? Whether it's x86 or an ARM-based CPU or anything, you can compile this and run on any environment. What this really does is it gives you the tools to really do anything. It empowers everybody and democratizes the equation for testability with an environment that is completely built on open source software data plane. Okay, there's no vendor dependency. You have a real platform, and you can extend both SONiC and VPP all by yourself with no help. Okay, that's the beauty of having SONiC VPP in your environments, in your service provider environments, or any environments that you're doing testing with a few set of nodes. You can build out your network, and you can run all of the tests and the automation and the SONiC CLI provisioning mechanisms all in your home network, right? So pretty much that's what it gives you. So today what we are trying to do is build you that story for what this engine can do as a development vehicle for data center testing. And beyond that, I see multiple sets of uses. And VPP has played in all those areas on the bottom right side. In various ways with different set of NOSes and control planes. VPP has already kind of seen the light of day in production networks. So you really can't do any of these with SONiC, obviously, and I'm not expecting SONiC to do all of these from the northbound, but there are ways that you can enable yourself to do any of these functionality. But let's keep the focus today to essentially the sandbox for data center testing. A quick background, VPP stands for Vector Packet Processing, and it's an FT.io project, like I mentioned. It's fully extensible, very highly optimized for performance primarily, and it builds on x86 architecture, caching, and memory infrastructure, makes packet processing extremely efficient, and it has all these vanilla bread and butter features already wired into the current version of Community VPP. And you can always extend that, right? All layer 2, layer 3 protocols, everything is ready for you in terms of VPP's capabilities today. It works on an architecture of directed graph nodes, and you can skip from one node to the other, and you can traverse a whole set of pipeline of functionality, and it can be programmed through any of these models. Why is it so good? It's so good because it can really pump 20 gigs of bandwidth on a single core of x86 today. If you're doing a 64-byte partial drop rate test with a say 0.005% of drop, you can get up to 20 gigs or more just for V4 processing. And if you're doing IPsec, you can get up to 40 gigs with an IMIX traffic flow. And it's really scalable. It's got low latency, and it uses all the x86 cache very efficiently. It uses AVX instructions. It does batch processing and no context switches, so that it can really perform as a real world router would, right? And so VPP is your engine here, and we are leveraging our work on top of this engine. And clearly we have capability with our skill set to be able to extend VPP, and it's actually not very hard, okay? So today, like I mentioned, VPP has all these features. We're bringing SONiC on top of it. It does vanilla layer 2, layer 3 switching and routing. And Len here, who's like the father of all of these capabilities, really would appreciate that this is still running, and this is what is gluing all our networks today. In this version of SONiC VPP that we're doing, we're adding all VxLAN capabilities. We are bringing SRv6 capabilities into the network, and my colleague Fred's going to talk a little bit more about those. Essentially with this, it'll complete a base set of vanilla router that you want to have for testing and building out your infrastructure, validating your your SONiC work or data plane or your automation infrastructure on top of this. And since both of these projects are running on their own trains, they have their own release modules, release schedules. SONiC it comes out twice a year, VPP comes out thrice a year, and we are constantly working with the leading edge versions of either one of these, and it's all upstream, and we have Git repos where you can download the packages and run with it, right? In terms of maturity, build footprint, and things like that, all of that is streamlined, packaged, and actually documented in the community on the GitHub. You can go ahead and read for yourself. In terms of footprint for SONiC VPP, on a typical 6-core Intel CPU, you can take 2 cores for SONiC and 4 cores for VPP. You will have a fully functioning router. You can optimize it depending on number of ports you want to expose yourself with. So it's ways to slice and dice your compute infrastructure and build out a series of these routers on an infrastructure that you want to test with, right? So all of this is very well documented. We'll show you pointers before we get off the stage. But this is basically where we are today, and I will hand it out to Fred for the rest of the conversation. Thank you.
Hello, everyone. Next, we are going to deep dive into the SONiC VPP design and implementation. So for SONiC, it expects the data plane, the ASIC SDK or the platform to implement the SAI API. SAI stands for Switch Abstraction Interface. It provides fixed operation on a set of objects, object types. The fixed operation basically include create, update, delete, and get. And it has about 100 object types. On the VPP data plane side, it's a binary API as a message passing API. It has 3 main message types: request and reply, with 1 request and 1 reply, and dump detail, with 1 request, multiple replies, for example, to get all the interfaces in the system. And also events. Event is 1 request for the event registration and 1 reply for the registration result. And then followed by multiple notifications with 1 occurrence of the event, 1 notification for 1 occurrence of the event. It has a large number of APIs. So here's we use IP route as an example to show how we translate between SAI API and VPP API. In this table on the left, the first column shows the SONiC operation, add, modify, delete, and get. The center column is the SAI API, and on the right is the corresponding VPP API. We can see for the modify, VPP does not support route modify, so we have to use delete and add. The translation of from SAI API to the VPP API is sometimes not trivial. It requires intelligent glue logic. For example, we need to keep the state, or sometimes we need to map multiple SAI API calls to 1 VPP API. Here's the view of the high-level components in SONiC VPP. At the top is the control plane components, and the control plane, it programs VPP data plane through the SONiC VPP SAI implementation, the SAI API. And internally in the SAI API, it uses a VPP binary API to talk to VPP. VPP runs in a separate process. And in VPP use DPDK to send and receive packet from interface. SONiC VPP can be packaged as a container or as a virtual machine. We have streamlined the SONiC VPP build for x86. Now it can build directly from SONiC build image repo, just like any other platforms. And SONiC use GMI, supports GMI and the rest for configuration. Also, we introduce VPP data plane API to existing SONiC API for data plane manageability and debuggability. Also, we use SONiC-Mgmt test framework to run SONiC VPP validation and sanities. Here's another view of the SONiC VPP architecture. At the top, the blue box has the SONiC control plane. It has CLI, GMI, and REST for configuration. It uses a Redis database to store application tables and config table. And SWSS is like a fib in SONiC. It programs data plane through syncd. And the syncd programs VPP data plane using the lib-SAI VPP.so. That's the SAI implementation for VPP. And internally, it is a IPC call to VPP through the binary API, because VPP runs in its own process. Inside the VPP process, typically it has one master thread for control plane and multiple worker threads. Worker threads is responsible for data packet processing. Depending on the number of interfaces and the throughput required, there can be multiple worker threads. In the example, for example, in the SONiC Azure T1 lag topology, we run SONiC VPP with 32 interfaces. There we use 3 worker threads. And then VPP use Linux CP or Linux control plane plugin for pump and inject packet to SONiC control plane. And netlink plugin is for interface to listen netlink event for interface up and down. We also add a VPP platform service into SONiC control plane. It is responsible for generating the startup configuration to be consumed by VPP. In the startup.configuration, it has memory configuration, CPU core configuration, and also, most importantly, the mapping from VM interfaces to the data ports in VPP. Here's the VxLAN feature we introduced recently to SONiC VPP. It supports V4, V6 VxLAN in-cap and decap. It's primarily for VNet peering. It supports V4 in V4, V4 in V6, V6 in V4, V6 in V6. And it supports multi-hop BFD for route protection. Also, it supports VxLAN, ESMP path, and the primary and backup path. We also add SONiC SRv6 support to SONiC VPP recently. It supports UN, UA, SRv6 policy, traffic steering over SRv6 policy, and UDT4, UDT6. Because VPP data plane already support the SRv6 functionality, the introduction of this feature into SONiC VPP took one developer about 3 weeks to finish the implementation. That's roughly how long it takes to add a feature if data plane is ready. And here's we use SONiC-Mgmt test framework for SONiC VPP sanity and validation. We have created a CI pipeline for image build, and we also create a CI pipeline to run sanity test that include interface, routing protocol like BGP, VxLAN, SRv6, and it uses PTF topology. It's a PTF-driven topology for T0 and T1, and currently we are primarily focusing on T1 lib topology. All the DOT and all the supporting peers like T0, T2, and PTF, they can run in one VM.
And you can say that it probably takes about 16 cores in Azure, at least for any of these topologies.
Right.
Yeah.
Right. In Azure environment, it uses about 128 gig memory and 16 cores. For VPP, VPP uses 4 cores. The SONiC control plane uses 2 cores, and the remaining are for the T0, T2 simulation. And here's another example of using SONiC VPP in topology. Last year in the OCP, we gave a demo on the virtual smart switch. We built the virtual smart switch using SONiC VPP as the NPU and BMV2 to implement the DPU data plane. It's a sandbox for smart switch development and testing with all open source components. And verification traffic can be sent from PTF and sniffed from PTF. On top of that, we can add T0, T2 peers to create a larger topology and run SONiC-Mgmt test. So we will use this topology to run smart switch sanity tests in SONiC-Mgmt. Here's the status of the SONiC VPP running in Azure. Our goal is to enable SONiC VPP as a PR checker to complement SONiC VS. SONiC VS does not have a real data plane. So many tests that requires data plane feature are either skipped or only run without traffic. That means there's some code coverage issue. Actually, recently, when we work on a SONiC VPP test failure, we discovered a bug in the SONiC-Mgmt test because of the lacking of this code coverage. And if SONiC VPP had been enabled as a PR tracker, such issue would have been caught earlier. Currently, SONiC VPP still runs nightly. We have 2 pipelines for build, one for 2505 branch and the other for master branch. And we also have a test pipeline that runs SONiC-Mgmt test on T1 like topology. And the recent test result is we got 460 passed and 1 failure. The failure we found is debatable because it caused by a memory check failure in one of the component. The memory usage is calculated using the memory used by the process divided by the total system memory. But because SONiC VPP has lower memory footprint, it has less memory. So the same memory usage appears with higher usage percentage. We will work with a SONiC team to improve the test case. Next step, we are working to promote build and test pipeline to PR tracker for both SONiC build image repo and SONiC-Mgmt. And we are going to expand to other topologies, T0, multi-ASIC, smart switch, and with more feature coverage. next I will handle it.
Yeah. Thank you for it.
Sorry. Thank you.
So yeah, primarily we are trying to encourage people who are going to look at SONiC in some level of seriousness. I know, SPs may or may not be on it yet, but the large enterprises looking at SONiC. So having this environment would essentially, speed up your validation and getting people onboarded to SONiC a lot more easily. And that's one of the key goals, essentially, for any data center roles that you may have in your networks. This slide is primarily showcasing all the current kind of users of SONiC VPP. Like Fred described, Microsoft is using SONiC VPP as part of the Azure CI. So are we within Cisco, eating our dog food for quick setup validation and tear down of various topologies. And when we say T1 and T0, these are kind of leaf and spine topologies in a typical IP fabric. So the SONiC test management suite that we talked about is geared towards that and definitely extendable to any other topologies. And you can add your own cases in the scenarios that you deem fit. All of those is perfectly flexible in the way you want to enhance either the test, you want to enhance SONiC, you want to enhance the data plane through VPP. You have full power to do that. With our other friends in Arista, guys like Steve, who was here from Nextstop, and others, Bell Canada, Pantheon, they're all kind of using SONiC for various, SONiC VPP for various test scenarios in their environments. Arista is trying to make some enhancements to do site test coverage, which is another gap in the community. And SONiC VPP provides a sandbox for validating that. They're adding more capabilities in addition to VxLAN SRv6 with IP and IP. Again, other bread and butter data center feature. Bell Canada is also using SONiC VPP for various infrastructure testing roles in their network. Pantheon, a startup out in Eastern Europe, is also using and demoing BGP multipath capabilities using IPVXLAN or EVP and multi-homing with SONiC VPP here. One of the power users of SONiC VPP that we have come across is Equinix. They are using that in a hybrid multi-cloud connectivity platform. Essentially, they're trying to do this gateway between all the cloud providers. So this SONiC VPP is really playing a good role for them, and they have a laundry list of features they want enhancements on, and we are going to be working closely with them. It kind of enhances the infrastructure with Equinix running infrastructure as a service. So these are some of the current set of users out there with SONiC VPP. And if any of you are interested, I would encourage you guys to come touch base with us. We do run this work group every week. We meet on Tuesdays online. It's part of the SONiC work group. If you go on the SONiC wiki, you will see a pointer to this particular work group, the virtual data plane work group. Our current focus is primarily related to infrastructure enhancements and features. And we want to complete the test coverage. We are not completely done with validating everything that's there in T0 and T1 roles that we mentioned as part of SONiC management. We have some more to go. We solicit help, and you can jump on it. It's a quick way for you to learn, make sure all those tests are passing in SONiC VPP, and then we have a real productive engagement after that to work on features and other enhancements that we want to build into the ecosystem. Like I said, we meet every Tuesday, 9 a.m. Just sign up on the mailer or reach out to me or Fred offline or today. Open to any questions, collaborations, ideas. I did meet with, I think, Naveen, somebody there in his team did want to look at SONiC. So it's a good starting point for somebody there. SONiC VPP will get you, your feet wet to get on the SONiC bandwagon. Sooner or later, you will have to deal with SONiC. So, this is one way to get engaged. And thanks to NANOC committee for taking this talk in. Really appreciate that. Maybe slightly outside the comfort zone of many other technologies in discussion here, but SONiC is going to be a little bit more spreading fast and wide fairly soon. So thank you, NANOC team. Any questions? Sure.
Yeah, do we support warm reboot feature with VPP?
Not yet, I would say.
Sorry,
Warm reboot.
no, warm reboot. Not.
Right, not yet. Yeah.
Yeah, with warm reboot, you require data plane runs separately from the control plane.
Exactly.
Right.
Yeah.
So I'm from LinkedIn, so we use 20K box, so we use warm reboot with F-order. So yeah, I'm considering this VPP, it's very good, but warm reboot is
don't.
the main feature.
But let's talk about that.
Yeah.
Maybe there is a way forward for that, yes.
With the Google Alpine, it's possible that going forward, because they run in a different container, the data plane and the control plane, right?
Right. So there's another project as part of virtual data plane work group, which is the Alpine project that's run by Google. And that's a split model of functionality between the control and data plane. And there, a warm reboot test with VPP is potentially possible.
Makes sense. Right. Thank you.
Any other questions? Thanks, everyone. 30 minutes to beer.
Thank you.